Hello students, welcome back to Algebra 2. Today we're going to start getting into graphing sinusoidal functions. Now the two sinusoidal functions are the sine and the cosine functions. So just like, just like the other functions that we've graphed so far in Algebra 2, we're going to start with a parent function. So the parent function of the sine and cosine functions are the simplest versions of the function, and that is going to be y is equal to sine of x. So in this case, the x is going to be the angle that we're taking the sine of. So we're going to start off by looking at this unit circle, and we remember in the unit circle that if this right here is theta, then sine theta is equal to the y value that it intersects on the unit circle. Now remember that in the unit circle, we start with the center at 0, 0 with a radius of 1. So for y equals sine x, starting right here, this would be a 0-degree angle. So at 0 degrees, when theta is 0, this point right here would be x is 1 and y is 0. So when theta is 0 degrees, the sine of theta would be 0. So we start off with this point 0, 0. Now as theta increases, for example, if it gets to 30 degrees, y is going to be a half. We discovered that in our last unit. And then if we get up to 45 degrees, it's going to be square root of 2 over 2. Those are all points that are kind of difficult to graph. So I want to go up to the next easy one to graph, and that would be right here. At 90 degrees, I get this point 1, 0. So right here, I'm going to say this is at 90 degrees, and I'm going to label this 1. At 90 degrees, the sine of x is 1. Continuing on, I'll get another easy point to graph, and that will be 180 degrees, and that gives me this point, x is negative 1 and y is 0. So at 180 degrees, it's going to go back to 0. At 270 degrees, I have this point 0, negative 1. Oops, I did this backwards. 0, 1. There. So at 270 degrees, I'm at negative 1. So that's right there. And then going around to 360, I'll return to 0 degrees. So right here at 360, I come back. Now connecting these, they won't go exactly in a straight line, so I'm just going to estimate a curve, and that's going to go like this. And there is the start of y equals sine x. And I say it's the start of y equals sine x because sinusoidal functions repeat each other. So you can see that if I were to keep on going past 360, this pattern would repeat over and over and over again. So there are a couple things that I want to talk about here. So the first thing is the amount of time that it takes to repeat. If I start at 0 and I go to 360, this is where the function starts to repeat. That amount of time is called the period of the function. And we'll start talking about what numbers change the length of the period in this case. Another thing that I want to talk about is there is this line right here that it kind of seems to oscillate around. So right here, this is 0 in this case. but this line, it goes up, it goes down, but it always returns to this line. This is called the midline. Now, if I start at the midline and then go up to the maximum point, I have a distance of 1. If I go down to the minimum from the midline, I also have a distance of 1. That distance right there, I'm going to call that A, and that is called the amplitude. Okay, so now that we've done that, let's go ahead and do the same thing for cosine. Y equals cosine x. Now this is very similar. I have theta right there, except in this case, I'm going to be talking about the x values instead of the y values. So starting right here, this is the point 1, 0, and then 0, 1, and then negative 1, 0, and then 0, negative 1. Looking at this, for cosine, we look at the x value instead of the y value. So cosine actually starts at the maximum at 1, and then as it goes up to 90 degrees, at 90 degrees, it goes down to the midline at 0, moving further at 180 degrees, the value is negative 1, so now it's gone to the minimum. And then at 270 degrees, it's back to 0. And then finally at 360, it's gone back to the maximum. So we have this graph right here for the parent function. Now, you'll notice here that for this parent function, the midline is the same. The midline is right here at 0. The amplitude is still 1. And the period is still 360 degrees. So for both sine and cosine, the parent functions have the same midline, they have the same amplitude, they have the same period. What's the difference between sine and cosine? Well, sine, the big difference here is that sine is going to start at the midline and it's going to start going up, where cosine is going to start at the maximum and start going down. Y is equal to A sine B x minus h plus k. Now, that might seem like it's a lot, but we've actually dealt with all of these pieces before. So let's talk about what all of these do to the parent function. So first of all, let's talk about the a value. So just like with quadratics and exponentials, the a value is the vertical stretch. Now, another way of thinking about the vertical stretch in sinusoidal functions is this is going to be the amplitude. In the similar way, B is going to be the horizontal stretch. Now, the big thing that the horizontal stretch is going to affect is the period. Now, B is not actually what the period is, but the period is going to equal 360 degrees divided by b. Or, if we're doing this in radians, it would be 2 pi divided by b. Now, h is going to be the horizontal shift, or in a lot of cases here, people call this a phase shift. And then k is going to be the vertical shift. And in sinusoidal functions, the vertical shift is also a quick indicator of where the midline is. Now, quick note, if k is 5, that means it's going to go up 5. However, if h were to be 5, if it said x minus h, that would go to the right 5. So just remember, horizontal tends to do the opposite of what you would think it would do. Okay, let's look at some examples. Okay, so let's start off with a very straightforward one. So the first thing that I see here is that this is a sine function. So the important thing about sine means that I'm going to start at the midline, and then I will be moving up. Since there's no h or k, that means that I'm going to be doing no phase shift, no vertical shift. So that means that the midline is going to be 0. The period here is going to be 360 degrees. And from that, we want to calculate where the critical points happen. Now, critical points are either midline, maximum, or minimum. Critical points are going to happen every period divided by 4. So that means every 90 degrees we're going to reach a critical point. And then we know that the amplitude is 4. That's this number right here. Amplitude is 4. Okay, so basically I can go ahead and start graphing this now. This is pretty straightforward. I'm going to say that my midline is here at 0. My maximum is going to be 4 up, and my minimum is going to be 4 down. So first I'm going to have, since this is sine, I'm going to start at 0. And then I'm going to start moving up. I'll reach the maximum point at my first critical point, which is at 90. So I'm just going to say that's 90 right there. And at 90, I'm going to go all the way up to 4. 90 later, I would be at 180 degrees. And at the next critical point, I'm going to go down to the midline again. 90 more degrees, I will reach 270. And that at that point, I will reach the minimum, which will be right here. And then at 360 degrees, I'll come back up to the midline. So I can go ahead and connect those dots. Remember, sine and cosine curve a little bit, so try not to do straight lines right here. And there is one period of the graph. Now I do want to go backwards a little bit just to show that it goes in both directions. So that's going to go here, and then here, and here, and then here. And I can connect those dots. And we're good. All right, let's try a harder one. Okay, so first thing, I see this is a cosine. So cosine means start at the max and then go down. Okay, there's no h or k, so that means my midline is still 0. So I'll go ahead and draw the midline in. I see right here that the amplitude in this case is going to be 1/2. So I'm only going to be going up and down by 1/2. So it's shrunk down quite a bit. Now in this case, I see that I've got a b value of 2 pi. Now when I see pi in these, I think radians. So I want to figure out what the period is. So I'm going to say real quick, b is equal to 2 pi. The period is equal to the parent period divided by b. So in this case, the parent period in radians is 2 pi, and in our case, b is also 2 pi. So that means that our period is 1. And then while we're at this, we should figure out the critical points. Critical points happen every period, which is 1, divided by 4. So the period means the function is going to repeat itself every 1. So I'm going to have a critical point every 4. Okay, so I'm going to go ahead and zoom in here. I know that my amplitude is only 1/2. So that means that right here and right here, that's my maximum and my minimum. I'm going to have a critical point every 1/4. So I'm just going to say that each of these lines is a 4th, just to make my life a little easier. So this is going to be 1/4, 2/4, 3/4, 1. So with cosine, I'm going to start at the maximum and then go to my next critical point is the midline. Next critical point is the minimum. Next one is the midline, and the next one is the maximum. Then I can just keep on repeating that pattern so I can get a nice cosine wave. And then we can connect these dots. Make a nice curve to this. And there is our graph. Okay, let's do some with some shifts. All right, so picking some things off. First thing that I notice here, we haven't done this one yet. The midline in this one is 3. So that means that I'm going to have, let's move this guy over just a little bit. In this case, my midline is going to be here at 3. The amplitude is going to be 2. So that means from 3, I'm going to go up 2 to get to my maximum, and then down 2 to get to my minimum. Now for this one, the period. Now this one is 4, so I could choose to do either degrees or radians and get the correct answer. I'm going to choose degrees just because there's no pi in this, so that seems like it would make my life a little easier. So the parent period in degrees would be 360, divided by 4 would be 90 degrees. That means my critical points would happen every 90 divided by 4. (22.5 degrees). Okay, so now what I can do is say that right here. Oh, I didn't identify this. Sine means start at the mid and then go up. Okay, so here's my starting at the midline, and then at 22.5 degrees, I'm going to go up to 5, and then 22.5 degrees later would be 45 degrees. It'd be right there. 22.5 degrees later would be 67.5 degrees, and that's where we would reach the minimum. And then finally at 90 degrees, we would reach the midline again. So we can go ahead and connect these. Then we should follow the pattern backwards. And there's our graph. Okay, one more. Okay, so 5 cosine 1/2 x minus 3 pi. This one looks a little intimidating, but it's not that bad. So, right here, let's go ahead and say cosine means start at max and then go up. Just kidding, down. You're gonna start at the max and then go down. We've got a 5 out front, so that means the amplitude is 5. Now, I don't have a k value right here, so that means that the midline is 0. So already I know that it's going to start at 0, and then, I'm sorry, the midline's at 0. My maximum is going to be 5, and my minimum is going to be -5. So my b value right here is 1/2. And what I notice over here is that I am going to have a horizontal shift that uses pi, so I should use radians for this one. That way I can keep the degrees and the pi's agreeing with each other. So that means that my period is 2 pi is the parent period, divided by 1/2 is 4 pi. Which means my critical points happen every 4 pi divided by 4 is pi. That's easy enough. Now, the new thing that we're adding in here is that this one has a phase shift to the right by 3 pi. So, my critical points are going to happen every pi. So I'm just going to say that each of these lines is a pi. Make this easy. So this is pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi. Okay, so normally we would start at 0, but we have a phase shift to the right by 3 pi. So that means I'm going to start to the right 3 pi right here, except cosine starts at the maximum. So I'm going to go up to the maximum, and there's my first point. Now, 1 pi later, I'm going to go down to the midline. And then 1 pi later, I'll go down to the minimum, back up to the midline, back up to the maximum, and then back down to the midline. So that means this one's going to be a very skinny wave. And then I can repeat this going backwards. Like this. I think a few periods is enough. And there we go.